Hello everyone, welcome back to Bamane Pharm lectures where we make pharmacy simple. In today's lecture, we are going to learn about body surface area as one of the most important parameters used to determine drug doses when it comes to posology. When we talk about posology, it's simply a science that deals with determination of how much of the drug should be administered to the patient. So I want you to pay a very keen attention because it is a very sensitive topic that mostly students find when it comes to theory calculations. If you're new to our channel, my name is Bamane and I am a tutor. And don't forget to like the channel, to share it with other colleagues who may also find it very interesting, and also to subscribe so that we can keep you updated with more simplified pharmacy lectures. Let's get started. What is body surface area? Body surface area simply refers to external surface area of the human body, external surface area of the human body. Therefore, our external surface area is what we are referring as body surface area, and it is expressed in square meter, which we sometimes call meters squared. It is a method simply used in calculating drug doses, widely used for two types of patients. That is, the cancer patients receiving chemotherapy and cancers, and pediatric patients, with general exception of neonates, because we know neonates are usually dosed based on the basis of weight, with consideration of a variety of biochemical, physical, functional, pathological, and immunological factors, not forgetting the age. Unlike body weight, body surface area considers weight, which is mainly measured in kilograms, and height of the patient, which is mostly measured in centimeters, making it a better indicator of body size for certain medications. And therefore, when we look at an average human or adult, is regarded to have a body surface area of 1.73 meters squared. And we all know that it is very difficult to measure body surface area directly, but we simply determine body surface area using the formula below, where we have body surface area is equal to the square root of product of weight times height divided by 3,600. The square root covers both the numerator and the denominator. Students often make mistakes where most of them, they only apply the square root on the numerator. That is wrong. The square root covers both the denominator and the numerator. But if we need to calculate the Charles dose, we calculate it from the formula where we have Charles dose given by patient's body surface area in meters squared divided by 1.73 meters squared, which we say that it is the average body surface area of an average adult times the adult dose. Or we can say Charles dose is equal to dose per meter squared being multiplied by body surface area of that patient. What is the relevance of this so-called body surface area? One, we say it is used for two types of patients. One are the cancer patients. Therefore, it is used to calculate chemotherapy doses. Secondly, it is used to determine pediatric drug doses. And lastly, but not least, it is also used to calculate doses of certain antibiotics. But before we can look at examples, we need to know that weight is always in kilograms and height is always in centimeters. So sometimes when we receive questions, the height is always given in either feet, sometimes inches, sometimes meters. So we should be able to interconvert from the so given units into the required units. So we know we have some common interconversions where we know that 1 kilogram is equal to 2.2 pounds, whereby in short we can say 1 pound is equivalent to 0.454 kilograms. And 1 meter is equal to 100 centimeter. For short, 1 centimeter is equal to 0.01 meter, and 1 feet is equal to 12 inches. But also 1 feet is equal to 30.48 centimeter, which if you convert to meters, we shall have a figure related to that. What are the common mistakes that students often make? One is forgetting to divide by the 3,600. Second is forgetting to apply the square root. These mistakes, we mostly see them when we are marking these papers. Lastly, but not least, omitting units. We know that weight is measured in kilograms. So if it is given in pounds, you have the work to convert it into kilograms. And height is always measured in centimeters. Let's look at our first example. Our first example. If the patient's weight is 50 kilograms and the height is 132 centimeters, what is the body surface area of the patient? Here, solution for the first example. They have given us weight, which we know 50, and they have given us the height. The height is in centimeter. Weight is in kilogram, which is very okay. So we shall simply just say from our formula, body surface area is given by square root of product of weight times height divided by 3,600. And when you compute this, we shall have 50 times 132 divided by 3,600, all of it under a root. So when we say 50 times 132 divided by 3,600, we shall get square root of 1.833 recurring. And when we get the square root of that, we shall have 1.35 meters squared as our answer. Let's look at solution for example 2. The patient has a weight of 60 kilograms and height of 1.7 meters. So the first thing we need to do is to convert the 1.7 meters to centimeters. But we know that 1 meter is equivalent to 100 centimeters. How about the 1.7? It will be 1.7 times 100, and therefore we shall have 170 centimeters. So that means we are going to say from our formula, body surface area is equal to square root of weight of the patient, which is 60 times height, which we have converted into centimeters, 170, divided by 3,600. And when you compute that, 60 times 170 divided by 3,600, then square root of it, we shall have 1.68 meters squared. I hope you're at the same pace with me. Let's look at our third example. Example 3. You can feel free to pause this video and calculate it out and see if you can get the same answer with me. The patient is weight has been given and also height has been given. But remember, weight should be in kilograms and height should be in centimeters. So our first point is to begin by converting these units into the required units. But remember, we know for solution 3, we know that 1 kilogram is equivalent to 2.2 pounds. That means that 1 pound is equal to 1 out of 2.2 kilograms. How about the 154 pounds? It will be equal to 1 out of 2.2 times 154. And when we convert that 154 divided by 2.2, we shall get 70 kilograms. How about the height? This has been weight. So height will be, we know that 1 meter is equivalent to 100 centimeters. How about the 1.75 meters? It will be equal to 100 times 1.75, which gives us 175 centimeters. So from our formula, we know that body surface area is given by height, which is now 175 times body weight, which is now 70 divided by 3,600. So when we compute this, 175 times 70 divided by 3,600 and the root, we shall get 1.84 meters squared. That is our part A of the question. They wanted body surface area. Part B, they required drug dose. But they have told us that this patient was prescribed a drug of 50 milligrams per meter squared. So that means if 1 meter squared gives us a dose of 50 milligrams, how about the 1.84 meters squared? This will give us 50 times 1.84 divided by 1. And when we multiply that times 50, we are going to get approximately 92 milligrams as the dose required in that case. And this is the answer. I hope you have gotten the same answer with me. Let's look at our fourth example. Solution 4. They have given us adult dose of amoxicillin, and they have also given us the body surface area. But remember, Charlotte's dose from our formula is given by patient's body surface area divided by the average body surface area times adult drug dose. So when we try to compute, the body surface area has been given to us as 0.95 divided by 1.53, which is a constant, times the dose of amoxicillin for an adult. So when we compute this, we shall have 0.95 being multiplied by 750 50 divided by 1.73. And when you compute this, we shall get 411.8, which is approximately 412 milligrams. And that will be the Charlie's dose in this case. In case you have any question, please don't hesitate to ask in the comment section. I will be happy to help you. And if you have any question concerning body surface area, please ask in the comment section. I will be happy to help you learn better so that you can excel in your theory and pharmaceutical lab practicals. Let's look at our fifth example. Our fifth example is going to be your assignment. Pause the video now and calculate it out, and the answer you get, put it in the comment section. I'll be there to tell you whether you got it right. And please, if you find this video useful, don't forget to like, to share the channel with your colleagues, classmates, and all students across the globe who may also need this knowledge so that they can excel in their academics. Also, not to forget, subscribe to our channel so that we can keep it grow, so that thousands of people out there can discover the channel and be able to learn while sitting at home. Don't forget that at Bamane Pharm lecture, we always make calculation is simple. Let's catch up in the next lecture, and please keep checking for any video you want. And if there is any topic you want us to cover next, drop your concern in the comment section. I'll cover that topic for you. Let's catch up in the next lecture.